Okay, so when you hear the words Microsoft Excel, what comes to mind? Budgets, right? Maybe some charts, endless rows and columns of data. I'm willing to bet you're almost certainly not thinking about 3D modeling. Well, today we're going to look at something that completely shatters that idea.
It kind of feels like a trick question, doesn't it? I mean, a spreadsheet is all about flat, two-dimensional grids. How on earth could it possibly create a three-dimensional object that you can actually see and, rotate in space?
And yet, here you go. Look at this. This isn't some artist's rendering or a mock-up. This is a fully functional pallet packing visualizer, and it was built from the ground up, entirely inside a standard Excel sheet. It's just a fantastic piece of ingenuity.
So how is this even possible? Well, we're going to break it all down. First, we'll get into Excel's secret power. Then we'll see how the 2D foundation is laid out before we jump into the code that brings it all into 3D. After that, we'll stack the layers and we'll finish up with a big takeaway from all this.
So first up, let's talk about the why behind this. This isn't just a cool party trick. It's a really clever hack that was designed to solve a very common, very real problem in logistics.
The challenge itself is pretty straightforward. If you're in shipping or logistics, you have to figure out the most efficient way to stack boxes on a pallet. When you do it right, you save a ton of space and money. But the software for that, it can be really complex and super expensive. Turns out the solution is hiding in plain sight. This whole system runs on something called VBA, or Visual Basic for Applications. It's the programming language that's already built right into Excel. It lets you automate tasks, including drawing and manipulating shapes, which basically turns this simple spreadsheet into a custom-built visualization tool. Okay, so how does it actually work? Well, like any good structure, you gotta start with a solid foundation. Before we can even get to the 3D part, we have to create the flat 2D components. And it all begins in the most familiar way you can imagine, just typing numbers into some cells. The user just punches in the dimensions for the pallet and the cartons right into this table. The code then just reads those values and uses them to draw the basic 2D shapes on the screen. And here is a beautifully simple piece of logic. To place a carton vertically, standing up, the code uses the height and width as you'd expect. But to place it horizontally, it just swaps those two numbers. It's an incredibly slick and efficient way to give the user total control over the layout. So once the user has arranged all the 2D boxes for a single layer, they click a Group button. The code behind that button then takes all of those individual shapes and just bundles them into one single object. This is a really crucial prep step before we can make that leap into 3D. And here it is. This is where the real transformation happens. Let's actually look at the specific lines of VBA code that take those flat grouped rectangles and give them depth and perspective. The absolute heart of this entire 3D conversion really comes down to a single command. The code selects the flat 2D palette shape and basically tells Excel, hey, give this a third dimension. The actual depth it gets is pulled directly from the numbers the user typed in earlier. Think of it like this. That depth property essentially extrudes the 2D shape. It's like pushing dough through a press. It takes that flat rectangle and just pushes it backwards into space to give it thickness. It's what turns a simple flat shape into a solid-looking 3D box. But, a 3D object isn't very useful if you're looking at it straight on. This next command is all about the presentation. It sets the virtual camera angle to an isometric top-down view, which gives us that classic, easy-to-understand 3D perspective that we're all familiar with. And finally, if you want to build a stack, you have to be able to control the vertical position. The code uses the .Z property for this. By setting the pallet's Z position to 0, it basically plants it firmly on the ground floor of our 3D space, making it ready to be built on. Okay, so we have a 3D pallet. Now what? We need to stack the layers of cartons on top of it. And the logic for this is just as clever and, really importantly, it's repeatable. The process for adding each new layer is really just a simple, repeatable loop. The code copies the 2D carton group, pastes a new one, applies the same 3D effects we just talked about, and then, and this is the key part, it calculates the new vertical position based on the height of the layers already below it. And this is exactly how the code automates all that stacking. The first layer is positioned on top of the pallet. The second layer is positioned on top of the first, using their combined height. The code simply keeps a running total of the stack's height and places each new layer at that level. It makes the whole process perfectly automatic. So after breaking down all that code, let's just step back for a minute and appreciate what this entire project really means. What we've seen here is so much more than just a clever spreadsheet. It's a powerful reminder that with a little bit of ingenuity, the tools we use every single day can do extraordinary things that we never thought possible. And this is why it really matters. This project takes a piece of software that almost everybody has and uses it to solve a genuine business problem, potentially saving a company a whole lot of time and, of course, the cost of specialized software.
It really leaves you with one final question to think about. What hidden potential is lying dormant in the everyday tools that you use? What problems could you solve if you just looked at them a little bit differently?